about that. Turbos. Lots happening in the turbo world. And a lot of people asking a lot of questions about technologies and really think it's worth spending just a few minutes on. So I don't know if we need to do a show of hands here, but I'm imagining that some people in here have some relevant questions about turbos and directions that have been gone by different aftermarket turbo manufacturers, and I am happy to oblige any questions about modern technologies that we're doing. I'm speaking to things like proprietary technologies that individual companies offer, as well as new products. Sidekick, for instance, is a word that 1 year ago nobody'd heard but me, maybe, and a few other guys. And now everybody knows what a sidekick is, right? Maybe not, but most people know what a sidekick is. So that's an exciting new technology. And what is it, and what's going on, and what's happening? In a nutshell, all of the turbo manufacturers have really efforted to move forward in electronics. That's where the big gains have been made. Better understanding of factory ECU tuning and how to alter it. Better control over relevant things like boost and ignition timing. Those are all big developments in the turbo industry, and so for people who haven't had a turbo sled that are interested in moving forward on one of those, this is a good year to do that. Things have really changed, and you'll see a significant improvement in runnability on 2017 product over previous years due to advances that a lot of the manufacturers have made. So I see some good stuff happening there. So I'm expecting that somebody's going to have some questions for me, and I'd love to run down some of these roads with you.
Intercooler or not intercooler?
Intercooler or not intercooler? I get that question a lot.
What I've heard on the internet is if you climb and see it's intercooler, you're looking at it.
Yeah, and if you heard it on the internet, it's got to be right. So, yeah, I recommend that as the first place to go for information. This is really a function of various gas laws, including Snell's law and other gas laws, combustion and temperature, right, or compression and temperature. So, let's just know this. When you exceed 8 pounds of pressure, you start to create temperatures that the motor doesn't prefer to tolerate. Will it? Yes. Will it run? Yes. Can you do 12 pounds without an intercooler? No, because you will melt. You'll actually heat the resin on the reeds enough that if you hold it wide open long enough, your reeds will never close again. And when you take them out, they're bent, curled. Empirical testing has proven this. It's indisputable. So there's a limit to the boost that you should run without an intercooler. Most people are running something similar in size to a GT2860 Garrett. That's the industry standard turbo. That's like the one that most fits most relevant modern two-stroke applications. So the GT2860, we've got variants, GTX 2860, that's a reference to the billet compressor wheel, a little bit different intake to that compressor, or an MTA or a KPA, and a lot of these are all sized very much the same with respect to compressor ratios. You guys don't need to know all of that. At the end of the day, just know that all of these turbos, when they exceed 8, you're starting to get into intake temperatures that will exceed 200 degrees. And intake temperatures over 200 degrees are not the preferred intake temp for combustion air. You start to create problems. At 250 degrees, you really create problems. So it's important. So 8.5, 9, 10, 12, no. Okay, so intercoolers, are they just for shoe climbing? No, not at all. It used to be the case that the intercooler air charge volume of the charge volume in the charge system on an intercooled unit was so big that most boondockers didn't prefer the throttle response trade-off with an intercooler. That's not the case now. All of the manufacturers have now efforted to create smaller volume systems, well, high flows. I don't want to say no volume because it's about volume, but the volume has to be in the right place. So there's not a huge trade-off. In fact, there's barely a discernible trade-off going from an intercooled unit or non-intercooled unit, either way. Intercooler adds complexity and weight. Most of them are liquid to air. There's different methods in which to apply that technology, and we can talk about what those are. The best result, we used to, I don't know if there's two basic ways, and I don't want to get into the science of it. You either have water surrounding an element that you run air through, or you have an element with water in it that the air rushes past. Those are the two, that's the simplest way to put it into how you can do it. The latter of those two is the most efficient. Thanks to NASA, that information is out there. So we now know that, and why we went the other direction, I have no idea. So they had that all figured out for us. It just took us a while to Google it, I think, maybe. But anyway, the rest of the industries answered the same thing. A cool element inside of the airflow is a far more efficient way to make that happen as far as weight versus result. You can get results either way. So intercoolers are great. Superchargers are, I get that question a lot. The supercharger is an awesome technology. It's applied to automobiles, particularly when you're married to a manual transmission. Anybody who's drove one can appreciate a supercharger. They're pretty good on an auto as well. I have to qualify that statement because it's really important that people understand what happens with a supercharger. A supercharger builds boost directly relative to engine RPM. I want that to sink in. A supercharger builds boost directly relevant to engine RPM. Okay? Why am I sticking here? This is the problem with it as well. It's a great technology. When you get everything working and playing right, it can be a very responsive system of boost. It is, no, I wouldn't say stock-like maybe, but it's certainly authoritative on the bottom. It feels good, it runs good, but we have this problem where as you go up in altitude, we have a reduction in engine RPM due to the fact that we're married to a CVT clutch system, and that results in an ensuing reduction in the amount of boost, which compiles or creates a bigger problem to reduce engine RPM and boost, and it's a constantly diving performance curve. So consequently, if you go down in altitude, superchargers don't like to compensate for altitude changes. It will rev too high. So unless you have a good load scenario, you'll have an engine that revs erratically and creates problems. So we have efforted to, and I've been involved in some of these efforts to create boost control systems for the superchargers. There's a reason why probably the automotive manufacturers haven't successfully done this either. They don't bother, because there's no way to bleed front-side boost off, you only create heat. There's no way to confidently bleed backside pressure off. That remains to be seen. We may stumble onto something that works, but as of right now, we can't control the boost, so we have to match the calibration to a specific altitude parameter. So you can have a guy that runs 8,000 to 10,000 feet, and he can confidently run that, but he takes that sled to 5,000 feet, and it's a no-go. You go to 12,000 feet, and it's a dog, a stalker's not running it, it's bad. Or you stop along the way, you reduce your pulley size or increase your pulley size, change your clutch weights, you're good. There's some people making some efforts to have variable clutch weight systems that are electronics, really cool technology. That could be a solution for the supercharger. Right now in the short term, the supercharger is great for specific altitude, not good for spanning broad altitude. Also, this is a really important point it's beyond contestation with respect to this answer that I get all the time, which builds more power. It's a stupid question. Really, there's a parasitic draw involved in driving a supercharger. It is mechanically driven. It's a fan mechanically driven off the engine. At 8 pounds of boost optimized versus 8 pounds of boost on a turbo, the turbo will outperform the supercharger every time, period. No hot rodder will tell you otherwise. But the supercharger builds boost quickly, relevant to engine RPM, and has a whole lot of other advantages. So if we could get a supercharger to work correctly, it would very likely be a solution for two-stroke guys. It is a little complicated right now, the way we drive them off of the flywheel and whatnot, but that technology's evolved, so it's showing merit, but it's still not a turbo yet. Turbos consequently do the opposite. So if everybody was kind of on board on that supercharger comment, a turbo, if married to a proper boost control, and that's a whole other subject because there are manufacturers that dodge this question of turbo systems, but boost control means that you apply the corrections to the wastegate or apparatus controlling the boost on the back side as you need to, going up or down in altitude. And what this means is, in an effort, because we're married to a CVT drive clutch, we have a specific set of parameters in the clutch that will result in the best possible machine acceleration because it's at a specific horsepower. So let's just forget what's aspirating the machine and talk about horsepower. If we set up a machine perfectly and clutched it perfectly, it would run the target RPMs perfectly at that moment. If we go up 1,000 feet or 2,000 feet or 3,000 feet, if we could still manage to maintain that exact target RPM, we've done our job really well, right? Naturally aspirated machines obviously don't do that. As you go up in altitude, the RPMs drop, as does a supercharger, but I said it compounds with a supercharger, right? Because the boost rolls off too, furthering the problem. A turbocharger system with a proper boost control will raise the boost as you go up in altitude relevant to the decrease in relative air density, and will maintain the exact same horsepower, 5,000 feet higher than it did before, requiring no calibration change. Very cool technology. That's the reason why turbochargers are far more popular in this application than a supercharger right now, because of boost control. So boost control is nothing short of probably the most important advancement that we've had in two-stroke turbo technology in a long time. How to control the boost, doing it both relevant to throttle position like some manufacturers like Boondocker do, as well as altitude, and others have different ways of feeding pressure to both sides of an actuator to accommodate for relative air density changes. Very cool though.